Unit 2, Lesson 1, Rational Equation and its Application. These are the things to understand. First, define rational equation. Second, solve rational equation. And lastly, solve problems involving rational equation. So first part is the definition of a rational expression. Rational expression is an expression that can be written as a ratio of two polynomials. It can be described as a function where either the numerator and denominator or both have a variable on it. Okay? So polynomial expression is an algebraic expression consists of constant, variable, and exponent that can be combined using operators. So let us consider the following expression below. X raised to 1/2, square root of x, 2 raised to x, and x raised to -2. So is this or are these rational are these expression considered rational? So the answer is no. So rational expression cannot contain a fractional exponent. Second, rational expression cannot contain radicals in the exponent. And also, it cannot contain a variable in the exponent. And lastly, it cannot contain a negative exponent. Okay? So next, this is the example of rational expressions. 1/x², x cubed minus x plus 8/x, x² plus 5x minus 6. So next one is about rational equation. Rational equation is an equation involving rational expression. 2/x plus 1 subtracted to 2 plus x/3x is equal to 1/4. So this is an example of a rational equation. Next, 5/2x minus 8 is equal to 7x all over 2x minus 1. And lastly, x minus 1/x plus 1 is equal to x cubed. So these are examples of rational equation. So next is about solving rational equations. To solve rational equation, we must follow two steps. Step number 1, multiply both sides of the equation by the LCD or the least common denominator, the rational expressions in the equation, to eliminate the denominators. Second, there are values or value of x that cannot satisfy the equation. Those value or values of x is called extraneous solution. These extraneous solution are not solution to the rational equation. Substitute the value or values of x to the original equation to determine if it is an extraneous solution or not. So let's find that out, or let's solve the rational equation. Example number 1. So we have here, solve for x in the rational equation x/2 is equal to x plus 4. So first thing to do is to find the LCD. So in this case, the LCD is 2. So next, we must multiply 2 to both expression in the equation. It will become 2 times x/2 is equal to x plus 4 times 2. So 2 times x over 2, so cancel 2, x. Then, in this part, we will distribute 2 to the expression, x plus 4. So 2 times x, 2x, and 2 times 4 is 8. So we have now x is equal to 2x plus 8. Then, combine like terms. So x minus 2x is equal to 8. So x minus 2x is negative x equals 8. Then divide both sides by -1. So x is equal to -8. So we have now the x value for the rational equation. But we must check it first to verify if it is a true that it is a solution in the equation. So how can we do that? So using the same equation, check if the answer is correct. So we just need to do is to substitute the value we get to the rational equation. So x/2 is equal to x plus 4. Substitute -8. So -8/2 is equal to negative 8 plus 4. Negative 8 over 2 is equal to negative 4. And negative 8 plus 4 is also equal to negative 4. So, since negative 4 is equal to negative 4, therefore, x equals negative 8 is a solution to the rational equation given. Okay, next problem. Solve for x in the rational equation 4 over x minus 2 over 3x equals 1 half. So again, let's find the LCD. So the denominators are x, 3x, and 2. So therefore, the LCD is 6x. Okay. Next, step number 1. After finding the LCD, multiply the LCD to the expressions in the rational equation. So multiply 6x times 4 over x subtracted 2. 6x multiplied to 2 over 3x equals 6x times 1 half. So 6x over x or divided by x is 6 times 4, 24. 6x divided 3x is 2 times 2, 4. And lastly, 6x divided 2 is 3x multiplied to 1, 3x. So we have now 24 minus 4 is equal to 3x. Then subtract 24 by 4. So obviously 20 equals 3x. Okay, then divide both sides by 3. The answer is x equals 20 over 3. So next, let's verify if the answer or if the solution is really 20 over. Using the same process in example number 1, we will substitute the x value to the rational equation. So checking. Substitute the value of x to the original equation. 4 over x minus 2 over 3x equals 1 half. Substitute 20 over 3 to x. So 4 over 20 over 3. Subtracted to 2 over 3 times 20 over 3 and equals 1 half. So 4 divided by 20 over 3 is 3 over 5, while 2 over 3 times 20 over 3 is 1 over 10. And lastly, equal to 1 half. Then subtract 3 over 5 by 1 over 10. So we need to make these two fractions similar in order for us to subtract. So it will become this 3 over 5 will become 6 over 10. Then subtracted by 1 over 10, 5 over 10. So 5 over 10 is obviously 1 half. So 1 half equals 1 half. Therefore, the x value 20 over 3 is really a solution to the rational equation. So next example. So it is a bit difficult. So we have x over x plus 3 subtracted to 2 over x minus 3 equals 8 over x squared minus 9. Okay. The denominators are x plus 3, x minus 3, and we will factor x squared minus 9. It will become x plus 3 times x minus 3. Since we have here x plus 3 times x minus 3, then that expression has x plus 3 and x minus 3. Therefore, the LCD is just x plus 3 multiplied to x minus 3. Then, multiply to the rational equation. So we have now x minus 3 times x plus 3 multiplied to the rational equation. Okay. So we have now x minus 3 times x plus 3 multiplied to the first rational expression, x over x plus 3. So cancel or eliminate x plus 3 from both numerator and denominator. So we will have, or we will be having x minus 3 times x. Then to the second one, 2 over x minus 3, eliminate x minus 3. So we have 2 times x plus 3. And lastly, eliminate x plus 3 times x minus 3 and x minus 3 times x plus 3. So we have now 8. So simplify. We have x squared minus 5x minus 6 equals 8. Further simplification, x squared minus 5x minus 14 is equal to 0. So we have now a quadratic equation. So we need to factor this. So the factors are x plus 2 times x minus 7 is equal to 0. So we have two values which are x plus 2 is equal to 0 or x minus 7 equals to 0, x equals negative 2 or x equals 7. So we need to test these two values of x to determine which of the two or if both of the two are a solution to the rational equation. So let's check. So using the same rational equation. So first is for the x value negative 2. Substitute negative 2 over negative 2 plus 3. Subtracted to 2 over negative 2 minus 3 is equal to 8 over negative 2 squared minus 9. So we have now negative 8 over 5 is equal to negative 8 over 5. So therefore, negative 2 is a solution. How about the other one? If x is equal to 7, so let's check. So 7 over 7 plus 3 subtracted to 2 over 7 minus 3 is equal to 8 over 7 squared minus 9. So 1 over 5 is equal to 1 over 5. So therefore, 7 is also a solution to the rational equation. So therefore, both x equals negative 2 and x equals 7 are solution to the rational equation given. So solutions are x equals set of 2 and 7. So next problem, given the rational equation x over x plus 2 subtracted to 1 over x minus 2 is equal to 8 over x squared minus 4. So factor first x squared minus 4. So we have now the new rational equation x over x plus 2 subtracted to 1 over x minus 2 is equal to 8 over x plus 2 times x minus 2. So like the example number 3, the LCD is x plus 2 multiplied to x minus 2. Then multiply to the rational equation. So we have now x squared minus 4 multiplied to this expression is equal to this expression multiplied to x squared minus 4. Okay? Then simplify. So we have now x times x minus 2 subtracted to 1 times x plus 2 is equal to 8. Okay? So distribute x squared minus 2x minus x minus 2 equals 8. Combine like terms. We have now x squared minus 3x minus 10. Okay? So the factors are x minus 5 multiplied to x plus 2. So the value of x are x equals 5 or x equals negative 2. So then let's check if these two x value are solution or not. So using the same rational equation, if x is equal to 5, substitute 5. 5 over 5 plus 2 subtracted 2, 1 over 5 minus 2 is equal to 8 over 5 squared minus 4. So simplify, the answer is 8 over 21 is equal to 8 over 21. So therefore, 5 is a solution. How about the other one? So the next one is negative 2. So substitute negative 2 over negative 2 plus 2 subtracted to 1 over negative 2 minus 2 is equal to 8 over negative 2 squared minus 4. So undefined. Because we have negative 2 plus 2, 0. So negative 2 over 0 is undefined. So therefore, the second x value is an extraneous solution and not a solution to the rational equation. So negative 2 is a extraneous. So the x value for this rational equation is only x equals 5.